Hello world, welcome to today's Tech Talk with our friend Eric Johnson from Amazon Web Services. I'll let Eric introduce himself and take it away so we can get started.
As Bernie said, my name is Eric Johnson. I am a principal developer advocate from AWS. And today we're going to be talking about Serverless 101. And this is really preparing for modern application development. Now, before we get started, let me tell you a little bit about who I am and why I think I should talk about serverless. First of all, I am, like I said, a principal developer advocate at AWS. I've been here roughly 3.5 years. I am a father of 5. That's not a typo. We have a crazy, fun, loud house. I am a brand new grandpa. There are not baby pictures in here, but man, it was close. I really battled that. I'm a drummer and I'm a foodie. I'm a lot of other things, but that's all I'm going to put on here. I love music. I love food. I love my kids. We have a good time. A couple things when I'm talking. I have some rules when I'm talking, and rules is kind of a strong word, but some guidelines that are going to help you out. First of all, the first rule is this. And this is, hopefully you can see this over video. This is any number I want it to be. I will say things like 7 or 22, but I just hold up one finger. So you have to listen to what I'm saying. These are thumbs and these are quotes, not apostrophes. Those are kind of some of the rules that I have when I'm talking. And again, they're guidelines to help you understand because, again, I'll say, hey, I need a table for 7 and they put me alone at the bar. So I do a lot of one-finger jokes. I was born this way, and I did not wake up this way this morning for the first time. That would have been I wouldn't be here on this video, I promise you that. But I like to make jokes and have fun, and hopefully you're not uncomfortable with that. Either way, I'll be comfortable, so we're good. We'll have a good time. All right, so as we get in here, here's what we're going to do today. We're going to talk about what is serverless. We're going to have a live demo. And then we're going to have, why learn serverless, right? Why is this important to me as a student? So I'm assuming we have a lot of students, but I'm not guessing we're all students. But why is it important to me as a developer to know serverless? Now, like I said before, this is Serverless 101. If you're coming here, if you're doing serverless now and you're coming here to learn, really advanced techniques, we're not going to cover that. I'll give you some links to where we do cover advanced techniques, but this is really to kind of introduce you to the idea of serverless. Well, what is it? How does it work? Why is it important? And just kind of the concepts. So with that in mind, let's go ahead and get started. All right, so let's jump into this. What is serverless? And to do this, we're actually going to go to the chalkboard or my digital whiteboard because this is I kind of want to talk through this. And feel free, I'm watching the chat a little bit. Feel free to kind of, if you want to give me some feedback as well, because we're going to be talking about again, what is serverless and how does it work for you? So let's get started here. All right. So in order to understand serverless, one of the things is we have to understand how what in our world we call legacy. Now, real quick caveat, you're going to see me looking down a lot of bit. I hope you don't mind looking at the top of my head when I'm writing. Also, when I'm typing, I tend to have to look at the keyboard because I never learned where to put all the fingers. So bear with me here on that. So, all right, so let's get started. When we think about building applications, and in this, we're going to talk about web applications because serverless is in the cloud. It works on the web. It also works with, you can mobile apps. It works with, apps that you build for Windows or for Mac or Linux or anything like that. You could build backends here, but we're going to talk kind of, on the web. If you're building a web application, what does that look like? So when we think about building a web application, the first thing we need is, and I am not an artist, so there you go. First thing we need is a server, right? And in that server, you're going to need some kind of firewall. You might have a firewall above, but you get the idea. Your firewall, you're going to have a server. It could be IIS, it could be Apache. You might have, you may have a database. You might have, there's all kinds of different things. You might be running Nginx, you might be proxying some PHP, all kinds of different things. So, but finally, and most importantly, is you have your code. Now this is the part that matters to you. Your code is what differentiates you from everybody else, right? This is the app we're building. This is what we want to, support, make money on, help people with, all kinds of things. So But again, in order to do that, you have to, a lot of times as developers, especially if you're in a startup or you're in, you're in a garage, it's two developers in a garage. What happens is you get this, you are responsible for all of this, not just the code, but all of this. Now, let's say we want to take this and we want to say, okay, but I'm going to build an application that I want to be resilient. Okay. So when we're building like, let's say we have a blog that just my mom reads, one server's fine. If it goes down, it's no big loss. But if you're building an app that's in production and it needs to be available all the time, then what that looks like is now, instead of just one server here, you now have to bring up multiple servers with the same setup, with your code in it and everything in there. And then you have to get a load balancer that load balances across those. And if you really want to do it right, you got to get those in different regions so that these are, so that if this one goes down, these are still cranking out data, right? So now, as developers, and you may be on a team that has ops and they'll build these out, but a lot of times we find ourselves doing this all by ourselves, right? And in enterprise, so let's turn that around. Let's say we have an enterprise, okay? And you come to enterprise, so we're going to go to a new page here, and you're sitting in an enterprise world, and they say, okay, we have an idea. We want to build a new feature or service for a customer. And you go, okay. Enterprise says, okay, that's fine. We have a team. We're going to build everything for you. So we're going to provision your boxes. We're going to get it all set up. We're going to patch and manage all that kind of stuff. It's going to take us about 3 months to get everything ready. That's probably a little exaggeration nowadays. But then what happens is you lose your agility because now you're waiting on folks. Okay, so with serverless at AWS, so here's your code on these, we feel like this is the only thing you should have to worry about. We feel like your code is all that matters and that everything else should have to go away. So this is where serverless comes into play. With serverless, we built the ability for you to take just your code here and run it inside of a Lambda function. And I always get that reversed. Could be one of those two. All right, a Lambda function is a service that we said all you have to do is give us your code, provide the event that's going to invoke that code, and we will run the code for you. You go, okay, Eric, hang on a sec. If that's the case, what about all that other stuff? I know for a fact, I'm smart enough, I'm a developer, I've been in this world for a while. I know that there aren't really no servers. And you would be right. There are servers in serverless, but you don't have to worry about it. Okay, so how we deal with this at Amazon is we've said, okay, what we're going to do is you have your code. Okay, this is the most important thing. This is where all your business logic is. This is where you may have some security going on, different things like that, right here in your code. What Amazon's going to do is we're going to, first of all, provide physical security. Okay, so we're gonna provide security around the data center. You could not go to a data center and say, hey, let me in, I want to take a look at where my code is. I don't even know where they are, to be honest. I can tell you where the regions are, but we protect the data center. The next thing we do is inside the data center, we protect the servers. We build, patch, maintain everything in order to use the servers. Okay, so now you're no longer worrying about that. We've also abstracted away and said, don't worry about setting up Apache or there's too many I's, IIS or Nginx or whatever. We'll give you a way, instead of having to have a server listen all the time, because if you think about it, if we go back to this setup here, in order for this to work for you, all these servers have to be listening 24/7, 7 days a week, 365 days a year. And that equals up to money, right? So if your traffic is, hey, we have real heavy traffic sometimes, sometimes it goes off. It doesn't matter. You still have to have these servers in place to handle all these, whether they're working or not, whether they're being utilized or not. Now, when you get into the cloud, like at AWS, you can say, okay, but I'm going to take advantage. I got you here, Eric. I'm going to take advantage of auto scaling. I'm going to scale out as I want to and scale back in. And that's great. If you're tied to machines like VMs or you need to use ECS or EC2, some of these container clusters or just virtual machines, then take advantage of that scaling. But the problem is it never scales to zero. Yeah, that's a zero there, but I actually did this. It never scales to zero. So what you're looking at is always paying for equipment, whether you use it or not. So with serverless, instead, we said, what we're going to do is we'll maintain these servers, and the only time you pay for it is when your actual Lambda is invoked. So when you invoke a Lambda function, and we'll talk about what that means to invoke in a second. When you invoke a Lambda function, what it does is if it's the first time ever, or not ever, but first time in maybe 15 minutes, give or take, it will actually create in one of these servers down here, it'll create an execution environment. And we will then load that code into the environment, and then it will execute your code. And that happens within milliseconds, okay? Depending on the language you use, but you're talking milliseconds, and that's sub 10 milliseconds. It's very fast. If by chance you've already had an invocation and that Lambda's sitting there, what happens at the end of that invocation, we freeze that Lambda. It's frozen in memory. And then the next event that comes in will actually invoke that same Lambda again. So what happens here is now we don't have a cold start, we have a warm start, and you even bring the response time even lower. So if you have a very busy traffic, then it's constantly being invoked, then it's gonna always be there and waiting for you. Now, what happens if you have a ton of traffic, right? So you say, Eric, that's great if I have one at a time and it's coming in. But what if I have hundreds or thousands of requests per second? What happens? Well, in that case, Lambda is going to start creating more what we call execution environments down here. And it will create them across, and actually I'm drawing these together, but they will be in different regions or different zones, of AWS. And these are isolated zones that keep you, so if this one were to have an incident go down, it would continue to work here and your customers would not see an interruption. And what we do is we can bring up to 1,000 concurrent Lambda functions at the same time. And I see a hand raised, and I'm going to give definite time for question and answer at the end of this, so or I'll grab some. So be patient with me, and I'm glad to answer them. So what happens then? These Lambdas scale out, and we have a lot of Lambdas coming up. They handle it, and it's the same code. So we bring up the same code over and over. They're called ephemeral. Or these Lambdas are ephemeral. Once it's done, it goes away. And then the next event will look for a warm Lambda. Remember, I said a Lambda that's frozen, and it will look for one and use that if it's available. If it's not, then we'll spin up another one. And we can handle up to 1,000 concurrent requests per request. And when I say concurrent, I don't mean per second. I mean at the exact same time. Now, there's milliseconds in a second. So if you have 1,000 hit in the first half of a second and 1,000 hit in the middle half, how you doing? I wasn't so good with math. And Harvard's like, really? 3 halves? Yes, there's 3 halves in this equation. The first third, let's say, is you have 1,000. The second third, 1,000. So you've handled 3,000 requests in a second or more. And that's a soft limit. We can raise that if you need it, but not a lot of companies actually need that much because they're staggered. Okay, so what we've got now is we're talking, first of all, I'm only paying for what I'm using. Second of all, it scales as I need it. Scales all the way up to handle my load, and it scales all the way down to 0. So if your traffic is stopped, you're not paying. And the nice thing, we're not going to go all into the pricing at the moment, but the nice thing is we offer a free tier, and it's a perpetual free tier. It's for life. Okay, it's not, hey, for your first year. That free tier gives you 400,000 gigabytes per second storage free, because we do charge on how much gigabyte memory you use. And then 1 million invocations for free. We have startups that are running full applications on serverless for almost free. They may be paying some storage costs or some things elsewhere, but they're able to take advantage of this. And so what's happened with serverless, or cloud in general, but specifically serverless, is we're taking, let's say you're 2 students sitting in a garage, you want to build an app. You have the same power that AWS or Amazon.com uses to support your infrastructure, but it scales in cost as your traffic grows. So you're able to start very inexpensive, and it's really fast prototyping. Okay, so that's kind of, hopefully that gives you the idea of serverless. So we only talked about one service, and that was the Lambda. And this is the important one, because this is where your business logic runs, right? You want to be able to run that logic without having to have a server up and running. All right, so let's go a little bit further into this, and we're going to talk through some of the services, but I want to take some time and actually show you how this is done, okay? Because it's you know, you're like, hey, that's great. We're talking concept. You're drawing really bad pictures for us, but we want to see what you can do. So let's go ahead and do that. We're going to jump actually into, we're going to do a demo. So let me jump around here. So we'll go to live demo. And for this, we're actually going to go to the code itself. So here in the code, now what you're looking at is my dashboard. Well, it's actually my Lambda function or list of functions that I'm using. And you can see a lot of different things going on in here. You can see I'd actually done some work around getting this ready for Harvard, things like that. So what we're going to do here is real quick, and this is actually live. This is DynamoDB. Here's Lambda. These are the Lambda functions. So we're going to just create one so you can see it. So I'm going to create a function, and I'm just going to call this starter. Okay, and we'll run it in Python, and you can see the different languages that we support out off the cuff, or out of the box, I guess is a better way of saying that. But you can also do what's called a custom runtime, where you can we have folks running COBOL, Rust, you know, R, all kinds of different things, Erlang. So in this though, because Python's about one of the only languages I know, we're going to use that. All right. So at the end of that, we can use x86 or ARM. I'll leave it x86 for the moment. That used to be our default. ARM is actually cheaper and faster, but we'll just leave it here for the moment. All right, so that's all I need to do. I'm going to create that function. I probably have to it's kicked me out. I didn't realize I timed out here. Give me a moment, please. All right, so y'all get to see me log in. Close this out. Okay, so let's try this again. So we're going to say starter, and we'll go to 3.9. I'm not going to lie, I panicked a little. Oh no, what'd I break? Okay, so that should get us going. So we're going to go ahead and create this function. Now that's actually what this is doing. This is actually saving the code and getting it ready to be invoked inside of the Lambda functions in those execution environments that I talked about. So it takes just a moment here. All right, so it is ready to go. So we can actually test this, but let's actually do one thing. We just released this feature 2 days ago. We're super excited about this. You can actually add an API right in front of a Lambda function without having to spin up another one of our services, which is API Gateway. It's also serverless, but it's a full, robust API system. But if you just need a real simple one, we're actually going to go here and we'll go into configuration, and I'm going to create a function URL. Right now, we're not going to worry about authentication at the moment. Cores will be fine. So it gives you an idea of what that looks like and the permissions. So we'll save this. And that quickly, I now have and let me blow that up so you can see it. I now have a backend that I can start developing on to build for, let's say, a mobile backend, or you need to build a full-on ML inferencing, or any kind of thing you can think of, a webhook for Slack, anything like that. I've not had to spin up any servers. It's secure. It's one of the things I did there is I showed you the security. It says, hey, this only this front end is allowed to invoke this Lambda. Right now, I've left it open. Y'all could go hit this if you wanted to. In fact, we'll get crazy if you want to see this, and I'll just post this if I can in the chat. Bear with me here. It's always fun in Zoom to find I may have to come back to this. Oh, here we go. I found it. Okay, so I'm going to post this hopefully into all. I may do CSS production. Maybe y'all can redo it here. So yeah, I just posted that. If you've got it, if you can repost it, that'd be great. All right. So let me go here. Close this out for the moment. So you could all hit this and it would handle all the traffic coming in. It would spin up new lambdas. We could all hit it. I can pound against this. Let's just refresh multiple times. You can't even see it. It's quick enough that it's happening. And there you go. Let's say I want to change it. Let's go in here. And so I'm going to actually edit the code. And I'm going to say under the code source where it says hello from Lambda, let's say hello CS50. I'm going to deploy that change. And if I go back to my website, oh, Eric can't spell what I typed for. There we go. It says hello CS50. Okay, I may have done that. That was weird. I've never seen that. All right, hello CS50, deploy. And I probably went too fast. There it is. There it is. Yeah, I think I caught it right as it was updating it. So that quickly, I can build that out. And I can go into the Lambda console and I can add triggers. So if we go back to our configuration, I can say I want to add a trigger here. That could be an S3 bucket. That could be any number of things. But let's talk about that for a minute, because one of the things I said is serverless is event driven, meaning instead of having a server sitting up there listening on a port like 443 or 80 or some customized port you're using, it just simply reacts to events. The Lambda service handles this for you. And events can look like anything. They can be a click of an IoT button. They can be an API call, which we're doing right now. This is actually an event. When you make a call to the Lambda service using that Lambda URL, it creates an event to invoke the Lambda function. You don't pay for that Lambda service to sit out there and listen. You only pay for that Lambda, for that event to be processed in the Lambda function. Okay, so it's very, very quick way of building applications in what we call EDA, or event-driven architecture. So we're going to jump in and kind of give you a little more depth on quickly building an application. And I'm going to walk through this for you. We're going to build from scratch a comment section here. Let me check my time here. I'm going to have to move pretty quick, but we can do this. But I want you to see how this works. So we're going to go over here to my code. And what we're going to do is, I'm on my desktop, and I'm using a product we call SAM, and that's the Serverless Application Model. And what this is, if you're into ops, you're developing, this is what we call infrastructure as code. I'm going to tell you why I'm going to use that. Now, I could go in there, like I just showed you. I could build a whole application pointing and clicking in the Lambda console, pull in API Gateway or S3 or one of our other services, and we'll talk about those in a minute. And I could build this out. But what happens when I need to rebuild it? Do I have to write all those steps down for everybody? Nah, that's not the way to do it. So at Amazon, we really encourage you to use what we call infrastructure as code. And it's declaring your application and infrastructure as code. So let's see what that looks like. So we're going to go ahead and initialize a new application. And so we'll just do one of our starter templates for the moment. And we'll use the Hello World example. And yeah, this is I'll use this common one. And so then we're going to call this Harvard. And now it's actually cloning those templates. So it'll take a second based on my internet speed. And then what it'll do is it'll create the app. And let's grab those down. We have a bunch of different templates that we use. And oh, look at that. I already have. Okay, let's do this again. Here. That was my bad. So we're going to say Harvard. We'll walk through this again. Hello World example. Yes. And we'll call it Harvard 2, okay? And it'll clone those again to make sure we have the latest. And then it'll actually, what it does is actually creates the directory and shows everything. All right, so we are ready. So I can CD into Harvard 2, okay? And then let's actually open the code so you can see this. So this is Visual Studio Code. And we'll line this up so we have it nice and big and everybody can see it. All right. And I'm watching the comments. Are these big enough for these? Okay. All right. And a second here. All right. So I am gonna have we have a question here. I wonder if they have a feature to prevent malicious actions. Like someone gets mad at you and knows you have a Lambda. Oh, it jumped on me here. someone gets mad at you, knows you have a Lambda function and uses something like DDoS, but for API calls to drive up your bill? That is a fantastic question. Built into API Gateway, you can use what we call a WAF, or Web Application Firewall, and we actually will handle DDoS for you. If you think, and I would suggest this, on that new feature we just did where you have a Lambda URL like that, you can actually put it behind a service called CloudFront, which is, it's our it's our distributed network, so it's global all over the world, so it's a content delivery network, and you can attach a WAF to that. It's a software WAF, so it's really cool. The way we do it at Amazon is you bolt on services as you need it. So hey, we want to use CloudFront to add to make that a custom domain, because that was a pretty long name that we saw there. But instead, we can say, hey, ericsdomain.com or ericswebsite.com, and then we can add a WAF, and that will handle DDoS. And we have preset rules in there that'll handle DDoS for you. If you use API Gateway, which is again our full-fledged service, it can have DDoS as well. So you bet. Security is the #1 thing we think about when we're doing AWS. So hopefully that answers your questions, and I'll come back to this in a little bit. So, all right. So let's go ahead. We've created this application, and in here, this is what we call our infrastructure as code, right? So what happens is this literally we have this example hello world function, and it describes a Lambda function. Now, I won't spend all the time going through this. In fact, I'm probably going to switch it out, and we're going to start building out an application. But I always start with a simple one here. So what we can do is we can go in here, and I'm going to actually bring up a terminal, and we're going to deploy this app. But I'm going to use our development. I'm deploying it to my development account. So I'm going to say Sam sync, because I want it to continue to sync, and we're going to do Harvard 2, okay? And I want it to watch. So what it's going to do, and this is a beta feature that I'm using, so I'm going to accept that, is it's actually going to build out the content. Now, some of you who work with Python, you're like, Eric, I know you don't compile Python. You're right, you don't compile Python. But what it does minify and get it in as small as it can, whether you're using Node, things like that, so that we can keep your Lambda packages small. Because each Lambda is packaged on its own. It's treated as its own ephemeral system. So, all right. So while this is deploying, let me talk through a couple things that I want you to see. So first of all, again, all we're doing is the Lambda function. Here's where I set that architecture. Remember, I said you can have x86. I point to the code that I want to use. And so what this says is the handler is going to be in a file called app, a function called Lambda handler, under a folder called hello world. So if I go over here and I go into the app, you can see here, and this is right out of the initialization, so you can kind of play around with it and test it. All it's going to do is it's going to return, it's designed to return through the API gateway, so it sets a status code, and then it returns a body, and that's just a hello world, right? So let's go ahead and check this out. So here you can see it's all done deploying, and it's sitting there waiting. Notice this hasn't gone back to my prompt, it's sitting there waiting. But what it did is it kicked out, let me go up here a little bit, it kicked out a API endpoint. So let's go to this endpoint. Go back to our browser here. And there you go. That fast, we have, how you doing? That fast, we have built, again, a backend, but now I could change accounts, I could change regions, I could send this to all y'all. That's a Texas word right there, all y'all, there's more than two. And you would be able to deploy this as well by simply saying SAM deploy. I use SAM sync in this because I'm going to develop with it for a minute, but SAM deploy would do that for you as well. So notice I didn't bring up any servers, I didn't bring up any databases, I didn't bring up firewalls, I didn't bring up any of that. It's all handled right here. So let's go back for a minute. And I can actually go in here, and this is where SAM's really helpful in deploying or in developing. This is the SAM CLI. I can go in here, and I can also say, hello, Harvard. We'll capitalize it this time. And I'm going to save that. And notice this picked up that I made a change, and it's sending out, and it's just finished. So we can go to the browser, and if I refresh this, hello, Harvard. Okay? So I've got a website. This is a backend for a website. Now let's do some things with it, okay? So let me update a few things real quick, and I'll explain what I'm doing. So the first thing we're going to do is we're going to add a whole bunch of new infrastructure. So I'm going to go into my template, and I'm going to actually replace all of this with new code, and then I'm going to change out some things over here. And what I'll do is when it's deploying again, I'll kind of explain what these are doing. So I'm going to create a feedback. Now, I'm not going to send it to y'all. You don't have to send me feedback, but I'm going to create a feedback app where you can say, hey, Eric, here's how we thought you did, or hey, here's what we think is serverless, or that kind of thing. Now, the first thing I need is when you're building serverless, you don't have to do it this way, but we recommend the following patterns, like keep it simple, dry, don't repeat yourself, single responsibility, only Lambda should do one thing and that one thing really well. Okay, so what we're going to do is we're going to create one Lambda function that is designed to read our database. Okay, so I'm going to call this read, and no, I don't want to skip changes. Okay, so we're going to read. Then I'm going to copy this. Okay, and we're going to make another one that is a write. Okay, and then we're going to do it again, and we're going to make this one is an eval. And this eval, we're actually going to tap into some machine learning today. And what I'm going to do is as stuff is added, it's going to evaluate it and say, hey, they liked it, or hey, this is neutral, or hey, that was really negative. All right, so first thing we're going to do is I'm going to go ahead and save this file because I want it to update the actual infrastructure. Then we'll change our code. So let me start this real quick, and then now Sam is smart enough to look at code and say, oh, there's new infrastructure, I need to run a full deploy and update all that infrastructure. Or it'll say, oh, there's code, so I'm just going to update the code itself. So, and that's really quick. You saw that earlier. So right now we're doing infrastructure. Let me explain a couple things. So I've got my read function, and it is triggered by an API call. And Sam's going to build, and we've already saw that Sam has that API that's going to do. The second thing is I'm going to have a write function. Now I want you to notice under my policies, again, like we said, one of the things, we are very big on security. So one of the things we do here is this Lambda function only needs to read from Dynamo. So we have preset policies, DynamoDB read policy, and I can dynamically grab the name of the table that I've built. And that is down here, and we'll talk a little bit more about that in a minute. So in the write function, I'm a DynamoDB write policy. It only needs to write. We believe in granular permissions, and it's also triggered by the API call. Now this last one is a little different, and this is when we talk, this is where it's important to talk about event-driven. I'm going to actually chart this out for you and show you what we're going to build. So if we go back to our sketching, so here we have me. Okay, hello, I'm waving at you. Okay, I'll just one arm. Okay, then the next thing we have is our API endpoint. Okay, oh wow, that's a really bad spelling of API. Okay, then what's going to happen is I'm going to send a request to the API. It is then going to invoke a Lambda, and that Lambda will then read from a DynamoDB table, which is a serverless database that we have. It'll return the data back to the user. The second thing I'm going to do is I'm going to have another Lambda function on a different endpoint. Yeah, no, I'm sorry. It's the same endpoint. It's the same endpoint. I had to think for a minute there. It's the same endpoint, but it's a different method. I'm going to use get versus post. Okay. So then what happens is when it's a post, it'll route to this Lambda function, which will then add data to the database and return a response to me. But the last thing I want to do is I want to evaluate that text. Now I could write that in to this code. Like I say, as it's coming in, I want you to use an ML service, but I don't have to. Instead, I'm going to use a thing called DynamoDB streams. As data is written to DynamoDB, it then enters the stream, and I can invoke yet a third Lambda function. I keep doing it backwards. You get the idea. And it will then invoke that, which will call a service we had called comprehend, and it evaluates a machine learning, one of our many serverless machine learning services. It'll then comprehend that line of text and write the data back to DynamoDB. So the reason I do that is all I care about is writing here. This is just to add data. This is just to read data. This one is to evaluate data. If I were to put it in here and something went wrong, then so if I put it into this one here and something went wrong, then I lose the data altogether. But if I just write it real quick and then evaluate it after the fact, asynchronously, or what we call storage first pattern, then if something goes wrong here and it blocks out, I've still got my data in my database. So this is event-driven architectures. It's very fast, and you're going to see that in just a minute. All right, so our architecture is updated. And here's that stream. I'm sorry. Here's that database here, and I'm turning on streaming, like I said. I'm just sending the old and new images out. Here's my event. I'm telling the Lambda function that anytime something appears in that stream, and I'm dynamically grabbing it, then I want you to invoke. But I only want you to invoke if the event type or name is an insert. Because I don't want to write data, have that go back to the stream, and cause a circular loop, right? Eric's done that before. I paid a huge S3 bucket. Oh, I'm not sharing the screen. Thank you so much. Okay, let me go back to that. There we go. So let me do that. So this is the event declaration right here on that function. This is that filter that I'm running. Here's where I'm dynamically grabbing the name, and I'm glad to share this application afterwards. So if I'll send the artifacts out so they can do that. Okay, so we've done this. So now what we need to do is we need to go ahead and update the code. All right. So what I'm going to do is we'll update the eval code first. Now, I'm going to say right up front, please don't judge me on my Python. I am an architect. This is what I do, but I am not an incredible developer, so, you know. But we're going to change this out. So this is what our code looks like. This is the actual evaluation. It gets the record coming in off the stream. It actually gets the item, and it sends it out to get evaluated by it, and then it adds that information back to the database over the same record. All right, I will need a couple requirements on that. The only thing I need is Boto3, so I'll change this out. And Sam will actually handle during the build. It'll grab the requirements needed. Boto3 is the SDK for Python. All right, so that kind of gives you the idea. Now that I've saved those, Sam's automatically going out and updating our Lambda functions. So in the background, this is happening for us. So the next thing I'm going to do is I want to update my, see, I've done my eval. I'm going to do my read function and requirements. So in my read function, and I'm not even going to try to kid you. I am not in any way typing these all out. Obviously, I'm copying and pasting. So in my read function, this simply uses, it sets a response to false. Then it actually tries to scan the table for any of these items. When it gets it back, it actually changes it from the DynamoDB format into a simple JSON, and then we send that out to the API. Okay, in order to do this, there's a couple of dependencies I need. One is Boto3. Pretty sure I said that wrong. And the other is just a library of DynamoDB JSON that does the marshalling. So I'm going to save that as well. All right. So, and then I'll save this real quick so that gets updated as well. And then the last one we're going to do is the actual write function. Okay, and if I'm missing any comments, Bernie, that I need to be seeing, feel free to interrupt me and jump on here. I know I'm going pretty fast, but feel free to interrupt me if needed. That's no problem. Okay, so the write function, again, just replace this boilerplate stuff. So the write function, what it's going to do is when the event comes in from API Gateway, it's actually going to create a UUID, so we have a unique UUID. It's going to load up the event body, and it's going to then, I default it to false, and then what will happen is we'll actually put the items on the database. So it'll create a record in DynamoDB to handle this. Then if that works, it sets, how you doing? Sets success to true. If it doesn't, it'll throw an error, and we can look at that in our logs. Finally, it returns just a simple, hey, yeah, it happened, it's in there. Okay, in order for this to work, I need 2 packages, Python packages. These are Bodo3, of course, and UUID. So we'll go ahead and save that. And then we'll save this. All right, so we've done a lot of work here. And we've basically updated our function. And as we've done it, it's been pushing these changes to the cloud so that we can test these. So what we need to do is somewhere up in here, we need to grab our API gateway again. And this time, we're going to use Postman to test this. Now, if you're not familiar with Postman, this is a great client to check it out. It helps you ping against APIs. Now, there's a chance this may not work, but that's okay, because this is live coding, so we fix things on the fly. But the first thing we're going to do is we're going to update our API, and we're going to check it and see if we get any records. And we don't. And that's expected, okay, because we haven't put anything in there. So the second thing we're going to do is we're going to go over to our post, paste this, okay, and then we want to actually add some data. So, all right, oh, here's one. I love Harvard, okay? So that's our comment. So we're going to put that in there. And then I'm going to go ahead and send that. And we got a success true back. So we know that it went through. So if we go back over to our data here, already, remember I told you that we're just going to insert just the ID. All we did was insert the comment, I love Harvard, and the ID. It was created in there. All this other stuff was done after the fact, asynchronously through an event-driven pattern. But you can see how fast it is. Now I know that because I say I love Harvard, it seems to think that is positive, you know? So we could actually go back here. We could change this to, let's see here. Eric is not too smart. Okay. So we'll do that and we'll send that and we get a true. Jump back over here. And that's negative, which I expected it to be. That's negative, you know? So hopefully that kind of gives you an idea how fast you can prototype and build an application. Now, it'd be very easy for me to go in here and I can throw on authentication. We have a serverless server, this service that handles authentication, or you can use like an Auth0 or something like that, where you had to log in to be able to send something like this. It's that quick and easy. All right, so that's the demo. So let's jump back out here to our PowerPoint. And let's go on just a bit here. All right, so what I want to do is I'm going to talk through some of the serverless services and what they do. Now, this is going to be really quick because I want to leave time for Q&A. But the idea here, we have, and these are not all of them. These are just a few of them. I've got 18 listed here. But basically what you're looking at are services that help you. You don't have to manage anything with these. Earlier we were talking with one of the folks on the stream before we started, and he uses Fargate. And Fargate's not listed here, but that is a serverless service to allow you to run containers. So you have a container, you can run it on Fargate. We have Lambda, which I talked about, AWS Lambda. We have Amazon API Gateway. We have this thing called AWS Step Functions, and this allows you to orchestrate. And when we talk about advanced patterns in serverless, we actually talk about, do you really need all that code? Y'all saw a lot of code in my application, and it worked. It was fine. But you'll notice there was no error handling in there. I had some try catches in there. There was no retry logic, and I could code for all that. Or I could use a service like Step Functions, and Step Functions directly integrates with things like Lambda Functions if you need to run your own custom business logic, or a service like DynamoDB or Comprehend, where you configure it and then you say, if that doesn't work, try again. If that doesn't, try again with a back-off strategy to the point where then we just dump it in a what we call a dead letter queue where we can troubleshoot that. Hey, Bernie, did you have something, or are you just popping on? All right, good. All right. You're muted, so yeah.
We're in our last 15 minutes here, so just want to be mindful.
Gotcha. Yeah, I should wrap up here shortly, and then I want to open it up for Q&A, so glad to do that. Okay, so a couple of the services you can see here. Amazon Event Bridge allows you to cross-region, meaning globally around the world, cross-account. You can actually, this is an event bus. And if you're a developer, hopefully you've heard of a bus, where I can drop events onto a bus and multiple targets, a Lambda function, a step functions workflow, DynamoDB, multiple targets can react to that based on rules. Again, no servers being set up, and you only pay for the actual events going through. We have a simple notification service and SQS. So that's, if you're familiar with PubSub as a developer, simple notification service is PubSub on steroids, very honestly. It allows you to send one message and have multiple subscribers, and they can be app to app, like another Lambda function or a third-party API, or they can be app to person, where you can actually subscribe with your phone number and you'll get a text message. I won't go through all of these, but hopefully you get the idea of different things we're doing. On the bottom here, I am listing a lot of our machine learning options that you can do in serverless. SageMaker is just that. You customize, you can build your notebooks, your Jupyter notebooks, things like that. Poly, which converts text to audio. Forecast, which can evaluate different types of data to forecast for you. Textract pulls out, looks at video, you can pull out text, all kinds of things. Again, I won't go through each of those, but you get the idea here is what we're driving at is, rather than you building so much into your code and having to manage the ops of servers and firewalls and routers and all that, you simply get to code again. You simply, as a developer, get to say, I'm going to run it here. Here's my code, run it. And within, that was about 10 minutes or 10 to 12 minutes that I built that app that actually evaluates text coming in. So hopefully that gives you that idea. So let me go here, and as students, again, we kind of are pointing this at students, and I want to talk through why Learn Serverless. Why? All right, Eric, this is cool. You've showed me the technical reasons, right? The scalability, the reliability, the cost. You've shown me those kinds of things, but what does that mean to me? And why should I learn serverless? Well, there's a couple things I would tell you. First of all is companies using serverless are not little companies you've never heard of. These are companies, these are on our website, Nielsen, Netflix, anybody heard of Ubisoft, gaming, things like that. Amazon.com, little website you can shop on. Neiman Marcus, iRobot, all of these, they use serverless in their applications, and they use it a lot. We've had a lot of them come speak at our conferences and talk about how they're doing that. If you've ever gone into, I know GCs, I don't know about Harvard students, but I'm going to guess you do too. If you've ever gone to Taco Bell's big and popular, and you've gone to the kiosk and you push the buttons to order your burrito with extra cheese and all that runs on serverless. That is programmed and running on serverless. It's event driven. It's a really killer architect. But more so, some companies are even doing what they call serverless first. And serverless first says, hey, everything we build, Liberty Mutual's talked a lot about this, Capital One's another one. Everything we build, we prototype in serverless first. And if it works, and the truth is, most workloads will work in serverless. Some are probably not the best fit. And in more advanced patterns, we could talk about that. But this idea of we're going to build it in serverless first, because number one, we can get it up very fast, and we can get a prototype very fast. That way our stakeholders can look at this. Two, we could go to production much faster, right? Because as companies, you need to get to production fast. You don't need to be waiting around for provision servers, provision firewalls, all those things. You need to get to production fast, but you need your cost to be low. And that's something you can do with serverless if done well. So all workloads are prototyped to serverless. You get the full story on a lot of these. I would encourage you, if you're curious about more customers using this, like Fender or different things like that, you can get this at s12d.com/customer stories, or follow this QR code. We have a ton of use cases where customers are using serverless to get on that. But you may be asking, Eric, you still haven't told me why I should learn that. Well, hopefully you're kind of getting the idea. If you're planning to come out with your CS degree, whatever you're using, and you want to get a job in today's world, this is a good tool to have under your belt. And here's the reason why. Half of all new applications built with AWS in 2020, this is back in 2020, are using AWS Lambda as their compute engine. This is not a little thing. This is a big thing. Companies all around the world they're getting away from data centers. They're getting away from managing their own infrastructure, and they're moving to just being able to deal with code. So for you, the truth is companies need help modernizing their application. They need fresh developers come in and going, there's a better way to do this. And what happens is we find a lot of folks are walking out the door from colleges and say, I've never heard of this. I don't know what it is. And so therefore the companies don't know about it. What we're finding is serverless is a highly sought after skill set in the market today. So as you're going out and you're looking for jobs, I tell you at AWS it is. And when we come there live, I'll have a recruiter with me and we're talking about how AWS can use you in serverless development. And the reality is for you, put simply, there's good jobs in serverless. There's money to be made doing serverless. This is a place where you can put your first, put down your foot in the first place and say, this is what I'm going to build. And especially with these companies that are just trying to modernize, you can raise your hand and go, I know how. I'm the one. I can help you out with that. One of the things I want to give you as we go out and we're going to do Q&A here in just a second is if you want to learn more about this, we have a website that we maintain called serverlessland.com. You can follow the QR code there. This has more learning paths, videos, blogs, all kinds of things. I encourage you to check that out.
Wonderful. Everyone, again, thank you so much for joining us today from all corners of the world. So happy to have everyone. Eric, thank you again for such a great informative talk, and I love your enthusiasm and energy. So once again, everyone, thank you. Take care.